Alright, welcome you guys. Today we'll be talking about AP Calculus, the fundamental theorem of calculus. Now I've drawn it out and I will talk about it and then I will give you some examples down at the bottom. Okay, but I need you guys to understand is when we're working on this stuff, let's use yellow. We haven't used yellow in a while. Okay, we're working on this stuff. The fundamental theorem of calculus is it just connects the two ideas of derivatives and antiderivatives. Okay. Alright, so if f is continuous on a and b, a through b, and that's inclusive, by the way, and the antiderivative of f of x, or of x, the antiderivative of f is equal to the integral from a to x of f of t dt, okay, where x is in this range. Okay, so in other words, what this is saying is that I'm continuous throughout this entire interval, and I can find the area anywhere in there. And if I can find an x in between a and b, then I can find the antiderivative at x. Okay. And so what this is that all of this is continued over here, and it's saying, well, if I do the derivative of both sides, then I find out that if I do the derivative of an antiderivative, I get the actual function. Okay, so in other words, it connects. It says that the antiderivative can be arrived by doing the antiderivative to a function, and the derivative can be arrived to by doing derivative of an antiderivative. So it's some really interesting stuff. But basically, it connects the two ideas behind calculus and stuff. Okay. Alright, so it just connects those two ideas and it bridges the gap between differential calculus and integral calculus. Okay, and we'll be talking more about integral next semester. Okay, so what does that mean exactly for right here? Okay, right here I have my actual function. I'm going from 0 to x of cosine of t dt. Okay, and so what that means is that when I do the integral of it, okay, I think of the antiderivative, sine of x, or sine of t. Okay, now some people use this notation where they put it in brackets. I honestly, I just like the straight up and down line. Okay, from x, okay, 0. I just like writing it like this because that's the way I've always written it. Okay. Alright, and so that's basically the sine of x minus the sine of 0 degrees and or 0 radians, whatever you want. And this is just sine of x. So in other words, I found the antiderivative of this by doing the integral of cosine of t. So the antiderivative of cosine of t is sine of x. Well, with respect to x. Okay, now if I have the integral of from 0 to x of 4x squared plus 5x dx. Okay, so what I'm going to do is I'm going to work my way backwards. Okay, so that should be 4/3 x to the third plus 5/2 x to the second plus c. Remember, whenever you're doing the antiderivative, you always have to do the plus c. Okay. Oh shoot, I should have done the plus c over here. Duh. Let's go back. Okay, so this one should have been plus c. Let's move it right there. There we go. Okay. Alright, now the reason why the c's disappeared here is because I have a plus c on this side. So let's say we had a plus c on this side, but I also had a minus c on this side. So the c's tend to cancel each other out. Okay. Alright, so I get this. This becomes 4/3 x cubed plus 5x squared plus c. Okay, and then it's going to be minus, well, if I started at, oh shoot, I accidentally typed a c in here. This should be a 0. There we go. Okay, On this one, I'd be typing in a 0, so it becomes 0 right here, plus 0, plus c. Okay, now you're going to think, oh man, I'm going to have c's again. No, because I haven't distributed this negative. Boom, boom, boom. Okay, and now it becomes the negative c, so I'm just left with the actual antiderivative or the integral, or the antiderivative from the integral. So it's 4/3 x cubed plus 5x squared, and there you go. Okay, all right, so it just works out that way. It's really kind of cool how it all works. Okay, so that's the fundamental theorem of calculus. It just connects the two, and you have to understand where we're going in the future. It's just working with antiderivatives and integrals. Okay, all right. Well, let me rephrase this. In the past, we've only used integrals to find area. Okay, especially in the area that we were dealing with, but now we can actually use it to find actual functions. Okay, or antiderivatives with this. Okay, all right. That's it for today. I will talk to you guys later. Have a wonderful day. Bye.